Have you ever looked at a world map and noticed how the continents seem to fit together like puzzle pieces? South America tucks neatly into the coast of Africa, for instance. It's not just your imagination. What if I told you that hundreds of millions of years ago, they were all connected, forming one gigantic landmass? Today, we're journeying back in time to explore the incredible story of Pangaea, the ancient supercontinent. So, what exactly was Pangaea? The name, derived from ancient Greek, means all lands. And it was exactly that. Around 335 million years ago, all of Earth's major continents slammed into each other to form a single, colossal landmass. Imagine a world with no Atlantic Ocean, where you could walk from what is now North America directly into Europe and Africa. This supercontinent was surrounded by a single, massive ocean called Pangaea, meaning all seas. The idea of continents moving wasn't always accepted. For centuries, people looked at maps and wondered, but it wasn't until the early 20th century that a German scientist named Alfred Wegener proposed the theory of continental drift. He gathered compelling evidence. He found identical rock formations and fossil species on continents that are now separated by vast oceans. For example, fossils of the land reptile Lystrosaurus were found in Antarctica, India, and South Africa. How could a creature that couldn't swim cross thousands of miles of ocean? The only logical explanation was that these lands were once connected. Wegener's theory was revolutionary, but at the time, he couldn't explain how the continents moved. So, for decades, his idea was largely dismissed by the scientific community. It was like he had a brilliant solution to a puzzle, but was missing a crucial piece. It wasn't until the 1960s, with the development of the theory of plate tectonics, that Wegener was finally vindicated. Scientists discovered that the Earth's crust is made of massive, rigid plates that are constantly, slowly moving on the semi-fluid mantle layer beneath them. This movement is the engine that drives continental drift. Life on Pangaea would have been vastly different from today. The interior of the supercontinent was likely a huge, arid desert. Being so far from the moisture-rich ocean, rainfall would have been scarce. Temperatures would have been extreme, with scorching hot summers and frigid winters. The coastlines, however, would have been more hospitable, supporting lush forests. Early dinosaurs roamed this land, along with many other strange and wonderful creatures. The formation of Pangaea allowed species to migrate and spread across the entire landmass, leading to a more uniform global ecosystem than we see today. But nothing lasts forever, especially in geology. The same forces that brought the continents together began to tear them apart. Around 175 million years ago, during the Jurassic period, Pangaea began to rupture. Magma from the Earth's mantle pushed up, creating rifts and causing the supercontinent to crack. This breakup didn't happen overnight. It was a slow, gradual process that took millions of years. The first major split separated Pangaea into two smaller supercontinents. In the north, there was Laurasia, which included what would become North America, Europe, and Asia. To the south was Gondwana, comprising modern-day South America, Africa, Antarctica, Australia, and India. A new body of water, the Tethys Sea, formed between them. As these two land masses continued to drift apart, new oceans began to form. The Atlantic Ocean started opening up like a zipper, pushing the Americas away from Africa and Europe. India broke away from Antarctica and began its long, lonely journey northward, eventually colliding with Asia. This incredible collision was so powerful that it buckled the Earth's crust, thrusting up the land to create the mightiest mountain range on Earth, the Himalayas. The mountains are still rising today, as the Indian plate continues to push into the Eurasian plate. The breakup of Pangaea had a profound impact on life on Earth. As continents separated, populations of animals and plants became isolated. This isolation is a key ingredient for evolution. Species started evolving in unique ways on their separate landmasses, leading to the incredible biodiversity we see today. Think about Australia's unique marsupials, like kangaroos and koalas. They evolved in isolation after Australia broke off from the rest of Gondwana. The continental breakup also changed global ocean currents and climate patterns, creating a more varied and dynamic world. So, is the story over? Not at all. The continents are still moving today at about the same speed your fingernails grow. North America and Europe are drifting apart, widening the Atlantic Ocean. The Pacific Ocean, on the other hand, is shrinking. Geologists predict that in the distant future, perhaps 250 million years from now, the continents will once again collide to form a new supercontinent. Some scientists have even named this hypothetical future landmass Pangaea Ultima. It is mind-boggling to think that the ground beneath our feet is not static, but part of a slow, epic dance that has been going on for billions of years. The story of Pangaea is a powerful reminder of how dynamic and ever-changing our planet is. It shows us that the world map we know is just a snapshot in geological time. From the clues in the rocks to the distribution of ancient fossils, the evidence for this lost world is all around us, telling a tale of an Earth you would barely recognize. Thanks for joining me on this journey back in time to the world of Pangaea. It's an incredible piece of our planet's history. If you enjoyed this video and want to explore more wonders of science and history, be sure to hit that like button and subscribe to the channel. Let me know in the comments what ancient mystery you'd like us to uncover next. See you in the next video.